So my name's John Stroll. I'm the Director of Research Analytics at Clarivate Analytics. Kind of what that means in practice, I work on the Insights product team. Insights is a bibliometric platform that we provide to our customers. I've been with the company for around 14 years now. My background is in sales and marketing, and I'm relatively new to product, being in the product team for about almost 18 months now. So as kind of the panel and I, or I and the panel, kind of put together this session or started thinking about this session, we really wanted to take a kind of a vendor agnostic approach. Kind of in that, kind of one, it's a conference. Two, we want to work collaboratively together to kind of unpick and uncover, what AI actually is. As you can kind of sense from the discussions, it's kind of that AI is very hot right now, but there's kind of so many different ways and applications and approaches that it can be at times quite confusing. So I think and hopefully you'll see it kind of emerging as we've been talking today about kind of one setting out that kind of that strategic vision in a way, or kind of what is it that you actually want to do. So in terms of what AI actually is, it's a tool that enables you to do something smarter, quicker, that you weren't able to do before, and trying to figure out how that actually fits into kind of your workflow, which John covered very nicely with the the various publisher case studies or use cases that he's described. And I think that gives kind of more of this tangible sense of, okay, well, perhaps we can use AI to solve a certain problem. In terms of my role here today, I'm looking at techniques and applications. So I will put my hand up to say I'm not a data scientist, kind of by trade. So a lot of this I have, gone through and almost coached it in language or in terms that I can understand, and I'm hoping to actually share that insight with you today. Kind of at Clarivate Analytics, we do have a data science team. They're based in San Francisco, and they also work remotely, actually. So we have a number of data scientists, kind of around the globe. And kind of within the newly formed ISI, we have actually kind of hired a new data scientist. So we are kind of actively putting new people into the team, which is great because hopefully it means that we can start unpicking these problems. But it does fall down to, okay, well, kind of one, what challenge you're actually trying to solve, and really the kind of is it the $64,000 question? That's the real question which you need to ask yourself. And in a way, just to reflect, is kind of as you look at AI and what it means. And for large firms such as Clarivate Analytics, for example, you have this Innovators Dilemma, which is when do you put your chips in? When do you play big in this space? Because we have existing customers, existing products and services which work very well, but we also have this new emerging technology which can change. And it can change very quickly. And I think that's I'm hoping that I can explore some of those technologies now to help uncover, kind of what are these big changes which may be happening, and how do we actually apply those in the respective lines of business that we're focusing on today. So in terms of, kind of neatly, surmising that introduction, I just wanted to, kind of define AI. Again, I know you've already had two explanations. Hopefully a third may, kind of get it right. This time I'm sure we'll have a fourth from Pauline. I'll go through some of the techniques, and again, these are, I'm not going to go kind of deep into kind of the clustering techniques and N vectors, which you need kind of possibly a degree higher than myself to understand. But I will try to, or I will kind of suggest reframing AI as more of a predictive capability to help kind of you understand where AI can be used. And then I'll just reference, kind of some of the accelerators, which is why we're actually sitting here today talking about AI. Because AI, is from my next slide, is not necessarily a new idea. Kind of in going back to the literature, it was, kind of the phrase was coined by this guy, John McCarthy, back in 1955. I think then there was a very large conference. A lot of this stuff is up online, and I've tried to reference some links throughout my presentation. Just for your own kind of learning. But there was a very large conference which, they kind of got all the movers and shakers together in the AI field to actually decide, well, what is artificial intelligence? And I took a kind of a screen grab from Web of Science. So I just searched artificial intelligence in Web of Science, and you can see kind of on the right all the different categories or the fields that artificial intelligence actually falls in. So in very broad terms, kind of it's this discipline which specifically focuses on computer science, but quickly expands into many other disciplines, and kind of I think this slide reflects it far better than I can explain it now. So there's this long tail of where AI can actually be used. And generally when we talk about AI, kind of leaping down the slide, one kind of there's this notion of general AI versus narrow or applied AI. And I think a lot about what we've been talking about today, and you'll see in my presentation, is more about narrow AI. So these are these point solutions. So, so what can I do better right now using kind of a technique? Whereas this kind of this notion of general AI, which is, I think somebody had termed it, I can't remember the reference here, is the holy grail. So it's effectively, kind of having a, kind of a sentiment robot, being able to deliver or have a panel discussion. And maybe that's a Turing test updated, is, can you put a robot on a panel and get away with it? So you'll have to, the question at the end of this is which one of us is a robot, but we'll leave that for later. And this, kind of, so when we're looking at this, or the screenshot of that brain there, kind of this is, really describing what kind of a human brain does, kind of almost intuitively. So many of you, I'm sure, have children, and you can, as you watch them grow and develop, they learn how to do things, and they learn on repeat by doing things, repeatedly. So I have a 6-month-old son who's trying to pick things up right now, and he's trying to learn how to sit, and he's trying to hold himself steady, and these are all things that you can almost watch him grow daily. So he's getting better actually grabbing things, and in a way, kind of, general AI is being able to kind of do all of this and apply one set of learning into another kind of discipline or another kind of another area, which is why we can have very good. I think we can have a computer can beat the world kind of chess player at chess or at Go, for example, but they can't go and get you a cup of coffee from Starbucks. That's a different job, and it requires a different set of tools. But a person can do all of this, usually competently, depending on the time in the morning. So looking at narrow AI, I wanted to try to unpick what this actually means, or what it meant to me actually as I was going through this. And so so narrow AI is trying to take apart what intelligence actually is. So kind of putting the artificial into the intelligence there. Kind of the domains I just reflect up there. Are very broad. So again, kind of today's talk, it's not just around kind of publisher specific. It's around kind of what AI can be used. And a lot of the time we're already using AI without even necessarily realizing it. For example, you turn on Netflix and a recommendation pops up. That's an AI recommendation coming to you. So that's built on an algorithm suggesting something that you used to watch. So as you kind of go through this, or kind of this unpicking of kind of what intelligence is, it's, I kind of coined it kind of thinking, learning, reasoning, and applying. And these are broad brush terms, so, and kind of within kind of this notion of thinking, you have kind of, quote, classic artificial intelligence. So this is, kind of giving computers the ability to actually mimic humans. It's called cognitive analytics. And this is where, kind of a computer is actually generating a hypothesis, kind of which is exposed as a recommendation. It ranks it, so it suggests it to you. And it's not necessarily led by rules or queries. And kind of that's kind of the old way of programming, where you had to program a rule in order to get, kind of the computer to do a task. Kind of the switch here with AI is that you can program the computer to do the task, and then it starts doing it on repeat, and it starts doing it for you. So it's actually unpicking insights which we didn't have before, and that's this kind of notion of thinking, or you look in the field, cognitive analytics, or I think IBM and their supercomputer. This is kind of the area which is called Watson. This is the area that they're really inhabiting. Learning, this notion of learning. So this is machine learning, kind of also kind of drips into deep learning. And machine learning and deep learning is what we've been talking a lot about today. And these are just, so machine learning in kind of its very, kind of neat sense is, kind of how do you classify an object? So how do you, kind of look at a picture and tell that this picture is going to be something? So you need to classify something before you can actually describe what it is. So machine learning helps us kind of classify objects, speech, pictures, whatever it may be that needs to be classified, we need to get it classified. And then deep learning is this kind of this application. We've just, kind of the buzzword here is this neural networks. So the computer's actually starting to think, and it mimics kind of almost kind of the human brain with all these different networks. And when we're using networks, and you kind of put it in the category of reasoning. Now, kind of the computer isn't reasoning in kind of the human form of kind of intuition and extrapolating meaning from a situation. It's kind of repeatedly running the same question again. It's kind of this continual feedback loop just to adjust itself. And this neural network, or this deep learning, kind of just through sheer computational power, is able to come up much more quickly with insights than we're able to do before. And then kind of the last area is around applying it. I put kind of the bucket of data science into this area. So not kind of true AIs or narrow AIs, we would see it. Because data science is more about kind of as a discipline. It's what you can be trained in doing. And I think there's actually a recent course which came out. It's now free online. I should have put the link, and my apologies for not including it. But you can then go and learn how to be a data scientist, so you can start to learn about kind of these statistics in these different visualizations in order to explain and understand data more effectively. And I think this is what John has been referring to kind of in the concept models, which is, from a publisher's view, if I wanted to, identify the next rising star in my field, can I use, kind of, is there a particular statistical technique that can help me do that? If so, what is it? And the data scientist can help you unpick that and then apply it to your problem. I mean, of course, just speaking beyond this framework, AI or kind of does also include robotics, smart machines, kind of drones. This all falls into the field of, quote, artificial intelligence. And again, kind of each of these is kind of answering a specific question which kind of the person or persons is asking of it. So in terms of kind of what is narrow AI, so again, kind of it's a busy slide, but I think it's helpful to try to go through some of these, and I'll explain by using the examples, because I think that's the best way to help kind of understand what it is that we're looking at here. And maybe one of the call-outs is that kind of as perhaps a practitioner, you don't necessarily need to understand how it works. You just need to know it will work and it can apply to a certain situation. So said differently is, you enjoy watching TV, and I can see somebody's got a laptop in front of them. You enjoy using it, but before buying it, you don't go, okay, well, which microchip am I working, and then how do the transistors connect? You don't necessarily need to know all that in order to actually use or apply the product. And I think the same is true with AI. Is kind of there are specialists who can help you understand and recommend these different techniques. And of course you can read and learn up on them, but you don't necessarily need to know kind of in the weeds, kind of all of this, kind of the different approaches, and that's why we have data scientists or specialists who help do some research to then come back with recommendations. And again, kind of the application in narrow AI is using kind of a mixture of these in order to answer a problem. So, looking, for example, kind of heuristics. So heuristics is just an approach to kind of get to the best possible kind of solution as quickly as I can. So kind of in layman's terms, it's kind of a very rough search. So if I'm searching for artificial intelligence in Web of Science, just typing in that, in a very broad brush, kind of gets me what I need quickly. And there's some tricks in AI, which is, kind of using heuristic techniques, which is kind of getting an answer to a problem very quickly. So it's, kind of, are there any shortcuts that we can use from looking at or mining data? Kind of within AI, there's this approach called support vector machines. So this is where we're looking at kind of a machine learning algorithm which helps classify objects or things. So an example here is spam email. Nobody likes getting spam email, and we'll probably get less of it now that Europe has decided to take action. But I'm sure it will still come through. And then how do you get rid of it? Well, the email needs to be classified. So there are algorithms which help kind of remove that and clear that out from your inbox. These neural networks that we've discussed on the prior slide, which is kind of how do you how do you see patterns in data? So this is kind of this notion of using a neural network to help understand it. They use something called back propagation, which is kind of a binary yes or no. So, kind of if object is this, yes, I will go this way. If no, then I'll go that way. And again, kind of a very clear example here is credit card fraud, which again has been kind of in play for many years. But if you're coming from overseas, for example, to Chicago, you may have got a call from your bank to say, what is that credit card transaction? Why were you at the bar last night? You don't normally go to a bar in Chicago, kind of midweek. And again, that's just an example of where, the credit card companies are using neural networks to help kind of identify who you are, create a cluster of expected behavior, and then, flag issues where, where that's not to type. I won't kind of explain Markov decision process, but this is more just a kind of aid robots, so kind of actually helping robots decide, or how do I unpick something. So I think your example earlier of how do I escape from a jungle at nighttime when it's dark, a data scientist would be using the Markov decision process to help build into, well, if you fall over, you need to get up and go back to your camp and then start over. So that's a rule that you need to implicitly program in to help unpick and guide, kind of the robot or the machine to do something. And then lastly, the natural language processing. So this is, how do you interact with your computer? So right now we're busy tapping away. Some of us may use speech recognition, but we also have chatbots. So you can type and you can talk to a chatbot online. Wall Street Journal has them. I think we have our own online support. You can start to type in. And the point here is that, this is, how do you interact with a computer? And there's ways, or there are techniques, and there's this field to actually uncover this and improve it. So going kind of more deeply into machine learning, this is kind of the one which is showing most promise today. I kind of just flashed up. I don't think you can actually have a presentation on AI without having a picture of a dog or a cat, because I think it helps explain the problem. But, kind of this is the dog. Yes, we know it is a dog. So what's that thing next to it, which also has 4 legs and is kind of furry as well? And I've taken this example from somebody else's. But the point here is that there are rules, and we need to train, and we need to help explain kind of this machine, or kind of help explain the algorithm in order to kind of answer the problem better. So, there's this, you do need to have training data. So kind of, how do you create an algorithm? You've got to train it. I think there's a question about social science data earlier. Secondly, you need to have input data to actually predict that, is this the right answer? And then you need to validate it. So you need to actually feedback and improve on that. So there's this kind of continual loop cycle which exists within machine learning. And a lot about this is, kind of taking data and then actually turning it into intelligence, which is something you didn't know before. And I think that's kind of one of the key points with this is kind of, can we use machine learning or AI as we're kind of colloquially using it to tell us something that we didn't know before? And I think that's the real power here, which is, not necessarily telling you that that's a very comfortable chair rather than a dog, but it's, you can apply it to kind of your own instance of how do I find that rising star from this panel of kind of people who've submitted to my journal, for example. So, kind of thinking around what machine learning or deep learning provides, there's this notion that they actually provide predictions. Potentially, kind of think through kind of the workflow or, kind of the problems that you're looking at, kind of as kind of, can we use kind of this algorithm to predict and to actually improve kind of the actual workflow. So here, if you're looking, I think we've referred it to it earlier as a point solution, but effectively what machine learning is helping us to do is answering a particular step in a problem. And I think the opportunity really exists to to rethink workflows. It's not to say I need to apply AI to my, kind of current product. At times you can. For example, within our own suite of products, we have a recommendation engine called Manuscript Matcher, and it can suggest a journal for a researcher to publish in. That sits on our EndNote platform, and it's a nice small tool, but it's effectively, that's a bolt-on, which is a piece of narrow AI designed to solve a problem, which is, how do I choose which journal to publish in? So, but I think there's this opportunity to actually think far more broadly about kind of the workflow, and then what are these workflows, and do they need to be re-engineered? And there's kind of a link there to to one from Google, which has over 1,000 projects currently on the go, looking at these new techniques. So potentially, if you're not doing something, you should be thinking about it. You don't necessarily have to take action, but it's just to be aware that there's a lot of activity going on. But then kind of also, thinking around prediction. So yes, it's great to have a prediction, but they can also carry risks. Kind of not up on the, one of the issues with machine learning is, or deep learning, is that we can't see into the algorithmic black box to understand, kind of how is it making these predictions. We don't necessarily know that. You can only see it from the outputs that it creates. So just a couple of examples here. One from the New Scientist, other from Fortune. Where, in Google advertising, it has race and gender bias. So, for example, CEO jobs is shown more frequently to men rather than to women. Why? Maybe because men are clicking on them more, I don't know. But, kind of inherent in there is a gender bias, which kind of now exists in the algorithm. There's kind of IBM facial recognition, which is more effective for white men. I think it worked 99% of the time, but if you're a person of color, and female, it only worked 35% of the time. So there we've got constraints within the algorithm. It doesn't work. It doesn't work effectively for kind of a very large group, effectively half the world of people. So there's a question there. And there's another one kind of in the US, which is this feedback loop where it actually sent more police officers to poorer neighborhoods because of this kind of feedback loop, even though their crime wasn't necessarily being committed in these neighborhoods. So again, you've got algorithms which are helping us uncover, identify kind of on new insights, but actually this is posing to be kind of real problems and challenges. And then also kind of the algorithmic discrimination in advertising. So Facebook actually took it down. This was back in 2017. But you were able to exclude certain racial groups from your advertising, which is, of course, it's strictly illegal. It should not happen. But it is possible. And again, this goes back to kind of how people are classified using our algorithms within the platforms that we're using. So again, it kind of raises almost some broader challenges about how should these machine learning techniques be used. We know we're at the cusp of this AI explosion, but it does kind of raise questions of exactly what are we exploding. And then kind of just my last slide, these are some of the main trends which which I think have contributed to why we're all sitting here today. And kind of on I think your left, the kind of the big purple buttons are, kind of things you've probably read about, heard about. I don't necessarily need to go through them in big kind of in heavy detail, but kind of the call out here with cloud computing. The reason why we're able to do a lot of AI now is that we do have. Well, one is they're very data-driven, and we've already talked about the need to have big data sets. So, we weren't able to do that before kind of the cloud existed. Kind of this notion of big data, we're now kind of producing far more data than ever before. But again, it's now available electronically. That's a recent trend which is starting to fuel this kind of this emergence. So we're able to actually apply the AI techniques, which we talked about previously, kind of to these data sets. I think you reference kind of AI API. So you don't necessarily need to have an AI expert in-house. You can actually buy an API. I think that I reference it here is the IBM Watson. And then again, kind of from Google, a lot of this is open source. So there's kind of this very, there's a movement to be open, to share, and to be free with algorithms. So if you are interested in using this, you can kind of call on Watson to actually provide a service to you, or you can kind of use Google TensorFlow to help give you some machine learning algorithms. So again, I guess you would need to have some background in data science and able to unpick this. But my point being is that these are tools which are available now to start and look at. And then lastly, kind of the other kind of buzzword which happens is kind of the Internet of Things, which is where devices are now connected and you have sensors kind of being embedded, for example, into automotives to allow cars to self-drive. And again, this is kind of another net new addition which we've just haven't ever seen before. And again, I think this confluence of these trends is giving us the ability to actually analyze data. So then in practical terms, it means we're analyzing it through kind of the workflows which we have. So and I think it really does go back to what is your workflow, and can you make that more effective by using these AI techniques. Oh, sorry, just my last one here, which I'll just flash up very quick. I think I'm over time.
You are.
But it's just kind of highlighting Google's growth in publications. I think this one I think is from Google Scholar, but the article does reference Web of Science, and I looked within Insights, our tool, and yes, their citation impact is 4 times the world average. So Google is publishing a lot of hot research in artificial intelligence, so it's definitely one to look at. They bought a company for $400 million in 2014. I think you can see that as the explosion in research. And then again, I think there's just additional ways that we want to think more about this, which is looking at, can we go or can we extend matching variable beyond what we currently are already using? Kind of this notion of broader access. This is, to your point on making AI every day. You don't want to think about the algorithm you're using. You just want the algorithm to help you get to your hotel on time, for the meeting, which is your, the Google Maps explanation, or this deductive reasoning. So, can we actually get new ideas from limited data sets? So not having to rely on such large data sets, because again, that's kind of a problem and can be a challenge to some people in inquiring. I won't kind of play the YouTube, but I think it will be on the slides, but it's worth also just sharing a DARPA perspective. Put a nice video up on YouTube. I think this was from 2016. It's about 5-6 minutes long, and would recommend you taking a look there as well. So thank you very much.